There's 3. Looking for 12 people who can tell me what that notation means. Abraham 4, Noemi 5, Jasmine 6, Giselle 7. Abraham, what does that notation mean? It's the area on the graph bounded by 4 things.
Point A to point B.
Okay, from point A to point B, even better, it's like the vertical line x equals A to the vertical line x equals B. What else? What else are the bounds? Eunice, what else? Okay, so you've got your x-axis, you've got the graph of f of x, you've got the line x equals A, you've got the line x equals B. That's all that notation means, and the fancy word for this notation is?
Definite integral.
Definite integral. One way that you can evaluate the definite integral, and it's probably your favorite way. Favorite way to evaluate the definite integral?
Calculator.
My favorite way is I graph this on my calculator, and I ask my calculator to do all the heavy lifting. If that's not your favorite way, you might need some special medication. Evaluating definite integrals on the calculator is a really good way to go. In about a month and a half, we're going to do it by hand with no calculators. Gosh, you guys are going to love that. Oh, it'll be almost as much fun as derivatives were. So anyway, that's the definite integral. That's what it means. We know how to find it on the calculator. But if the question was to estimate it, George Riemann came up with 4 ways. 4 ways that you're all responsible for knowing. Mariah, what's one of the 4 ways?
Left endpoint method.
Left endpoint method. Jose, give me another way.
The right.
The right end. Way to think there. She did the heavy lifting here. The left endpoint method. The right endpoint method. Jennifer Ortega, what's another method?
The right.
No, that's his way. Don't mad dog her. Turn around. Left endpoint method. Right endpoint method. Left endpoint method. Right endpoint method.
The midpoint.
The midpoint method. And David, the last one? The trapezoid method, okay? All those methods are ways to estimate this area. So in each case, what was the fancy word? Am I chop it up?
Partition.
Partition. I'm going to chop up the interval. And if I tell you make your rectangles and you start making your rectangles this way, what method am I using? This is the left endpoint method because I'm using the left point. The right endpoint method, if I grabbed a different color, I would say, okay, on this interval, go up to the curve, over and down. I'd go up, over, down, up, over, down. And in that case, I'm doing the right endpoint method. Edgar, how does the midpoint method work? The name says it all. The left endpoint method, I used the left point on the interval. I went up to the curve, over and down. The right endpoint method, I went to the right point. I went up to the curve. I went over, I went down. The midpoint method. Daisy, what are you going to do?
You go to the middle.
You find the middle, and then?
And then you go up.
You go up to the curve. That's going to determine the height of the rectangle, and you make a little rectangle. Trapezoid method, what's different? You're still going to use all these sides, but now you're like connecting them to make your little trapezoids. And the area formula for trapezoid, everyone is responsible for knowing.
1/2 times base.
1/2
Times height.
base 1 plus base 2 times the height. We're okay?
C.
Good. All right, homework's in the middle of the table. So now it's time to upgrade your skills. We're going to go to an application problem. Oh, so excited. Here's what I want you to do. I want you to take 1 minute. Read through this problem. I want you to mark this up. I'm going to take attendance. I'm going to pick up the papers. Read through this problem. Get your head wrapped around this situation.
After 7 days of enjoying the stream.
Read it to yourself. It's your inside voice. just know if you were ever in a crisis and you called me over, I would approach it first, like a mathematician. All right, so Christian, what's going on in this situation?
There's water leaking out of the pool.
So we've got a swimming pool, and we've got water leaking out. So like, here's my pool. And for whatever reason, water is leaking out of the pool. What does this function represent? Let's get some hands on this. What does it represent? What does the function represent? Nora, what does it represent?
The rate at which water is leaking, so gallons per minute.
So rate that water is leaking. And I love what you said next. Rate that water is leaking. What am I measuring in?
Gallons per second.
Gallons
Minute.
per minute. So if I'm reading the graph at time 0, how fast is water leaking out? At time 0, how fast is water leaking out?
300.
I'd read this and say at time t equals 0, water's leaking out at a rate of 300 gallons per minute. Easy question. If the water was leaking out at a rate of 300 gallons per minute for 4 minutes, how much water comes out? Water's leaking out 300 gallons per minute for 4 minutes. How much water comes out? 1,200 gallons. David, is the water leaking out at a rate of 300 gallons per minute?
Only at x equals 0?
How about t?
Oh.
Right, so on this axis we're measuring time and the units are minutes. And on this axis we're measuring r of t, and that's going to be gallons per minute. And I love your answer. You said at time t equals 0, the water is leaking out at a rate of 300 gallons per minute. But is that happening for the entire 4 minutes? No, it's happening for like an instant. And an instant later, we're leaking out at a different rate. An instant later, a different rate. An instant later, a different rate. So let's have a conversation about, we're going to flip over to part B. In part B, it's on the top of the next page. The first question is, what does that actually mean? This integral from 0 to, where am I going? 0 to 8, r of t dt. My first thing that I'm interested in is what does it mean? The second thing I'm interested in is what's the actual value? What would that actually mean? The integral from 0 to 8 of r of t dt. Jennifer, what would it mean?
The rate of water from 0 minutes to 8.
R of t represents the rate, and this is a rate that's being measured in gallons per minute. I agree with you on that. I don't agree with you on the meaning of this notation, though. R of t it's the rate that water's leaking out. The integral from 0 to 8, a popular wrong answer, is to say it represents the area. Now, does definite integral represent area? Does definite integral represent area? Yes. Absolutely. But when I'm talking about a rate function, when my units are things like gallons per minute, that area takes on a new meaning. It's going to represent, that integral from 0 to 8 is how much area there is between 0 and 8. But in the context of this problem, what we're going to say that this represents the total number of gallons. Total number of gallons that leaked from t equals 0 to t equals 8 minutes. Okay. You're only going to talk about, you're going to describe this as an area if we're talking about just a generic problem. There's no units, there's no context. But R of t is your rate that water leaks out in gallons per minute. The definite integral is going to represent that total amount of water that leaks out, and the units here are going to be in gallons. And if you're not sure about that, think about if I took any little slice here. The way I'm measuring the height, the units are, what, gallons per minute? GPM, sure. And the units over here. The units on the x-axis. The units. The units over here are minutes. We are measuring time, but I'm measuring the time in minutes. If I take gallons per minute, time minutes, gallons per minute times minutes, the minutes are going to cancel each other out, and I'm going to get gallons. Oh. The units tell it all. Okay, real quick. Using your calculator, I want to know the exact value. I want to know exactly how much water has come out.
Did you do it? Already?
A good idea would be to graph this function so that it shows up on your calculator. And then you can call it F1 or you can call it F2. You can call it whatever you'd like. Okay, Jonathan's got 1,133.070. Anybody else getting that? Okay, that doesn't seem like a whole lot of folks getting that answer. I'm gonna wait for 10 folks. Jonathan, what was your number one more time?
I got that.
1,133.070
07.
or 071, and the units have to be? The units have to be gallons.
I agree with John.
Okay, and you agree with Jonathan. Anybody else getting 1,133 point stuff? Now, there will be times where you will need to round. There will be times where you'll be told in the problem to round. If they tell you to round, follow the rules of rounding that they tell you. In part B, are you guys told to round?
No.
No one's being told to round.
It just says exact value.
Okay, find the exact value. We're going to call that the exact value. Your calculator's doing all the heavy lifting. What I care about right now is an understanding of the units and the meaning in this context. Don't tell me area, tell me how many gallons. Okay, yep.
So the area would equal the ground.
The area that you get, the numerical value that you get is going to represent that many gallons that leaked out. Not how fast, but how many. So here's what I want you guys to do. I want you to see what you can do with parts C and D. Part C should really only take 2 or 3 minutes. At 11:15, I want to check in with everybody so that we can tackle part E together. Your homework tonight is going to be to finish all of this and get this turned into me. So you get like the next 7 minutes for some good calculator practice. Jennifer. So the answer that you get when you get it. So all I did was have a little area there.
Because T doesn't work.
Okay. I want you to look at your graph compared to my graph.
Like that's the
Not
right
getting the
thing.
same graph that means you type something. Because I've given you the equation at the end of the graph. That means it has to be correct.
R of
So by 2?
So look at what we typed in.
2.
So we're not going to where are you going to go?
R of
Yep. Now you're doing C and D. And make sure you show me all the work.
That's an example. You multiply the 2 times all of these.
Yeah.
Do you do R of 0 though, right?
No, because it's finite.
This to the root.
If you always do that, you would start with this
This
way.
way, that's an exact value from the calculator.
Except on my calculator, there's a whole lot more decimals than what I'm actually choosing to write down on paper. So I am doing that.
This is incorrect?
Well, there's even more decimals after that. So writing the approximate. Would you include 10? You're going to go from 0 to 10. So you're going to chop 0, 2, 4, 6, 8, and 10. That first interval goes from 0 to 2. The equation gets that.
That's 27 last night.
So you start with 2. Now the next interval is from 2 to 4. Which is right at Good question. We'll talk more about that tomorrow. How are you doing?
What'd you get? 925.402. 925.402.
Can you show me what you grabbed? What does your calculator think of one is? What happened when you did this one? You said instead of typing in F1, you said 0 to 8, 300 divided by x squared plus 10. That's what you did. But then in this next one, now you're calling up some
Describe what
function
it's
in F1. But F1, I think, is from the homework that you did last night.
For the homework, I just said like it's an underestimate because it gives the gallons.
This
Well, for
function
this assessment, it's an underestimate because it gives the gallons
Okay.
under the curve.
Friends over here, how's it going?
For like when we describe if it's an underestimate or overestimate, can we just like directly refer to the graph?
Exactly, it has everything to do with the graph.
So would you say gallons or area here?
So the
It's
answer that
gallons
you're
is
getting
area.
is gallons.
So it gives the gallons under the curve.
Yep. Now, I've got my picky pants on. Always.
R2.
Always have the picky pants on. Your function's not named F.
Is R.
R.
And then you just go here and throw this. And then I start.
Okay. All right, we've got about 3 minutes left before I pull everybody back together. Daisy's group, Jasmine's group, and Nora's group. I want you guys to do part D, part 1, which is the left endpoint method. Part D, part 1. I need you guys to get an answer for me in a little bit. You guys over here, I want you to do part D, part 1.
Shows the rectangle.
That's the right endpoint method. I'm looking for a number and explanation of overestimate or underestimate.
But you don't have it up to 20.
Just imagine it. Limits us right there.
125.
I'm gonna go home and knock out.
Really? So you don't have any hours to do?
I can't do it today. I gotta watch the game. I gotta do it next Wednesday.
Next Wednesday is when they're due.
That's the 16th. No.
What you used to do?
So 5
That was a funny thing. It was iconic, honestly.
Yes, we.
Wait, what are the answers to think? No.
Okay, so left endpoint, it would be 0, 5,
R5 and
10,
R10.
15.
Wait, how do we know which one to use?
Tells you.
Oh, 4 rectangles.
Yeah.
Just divide 20 by 4.
20 divided by 4 is 5. Five, so 5 times R.
So then when you're doing 5, 10, 15. Okay, you got it right.
All right, left endpoint side of it. If I get everybody to stop what you're doing for a little bit, Martier, tell me about, you guys were just doing left endpoint method, right?
Yeah.
Now I realize you may not have gotten it all tucked into your calculator, but if I'm going from 0 to 20, 4 rectangles equal width, right, my partition's gonna be 0, 5, 10, 15, and 20. Everybody on both sides good? Whether left endpoint method or right endpoint method, your setup's the same. But Martyr, tell me about that first rectangle.
It would be R2. Or
It's going to be
I
how?
distributed the 5, sir.
Wait, one more time.
I distributed the 5.
Okay, but tell me about the first rectangle. How wide, how tall?
It's R0.
R0
Uh,
is the height, and then times 5, right? And then the next rectangle, hopefully, you've got 5 times R of 5, 5 times R of 10, 5 times R of 15, 5 times R of 20. And what I heard you say is you didn't want to bother writing the 5 every single time. So you factored out the 5, and hopefully R of 0, R of 5, R 10, R 15, R 20. Everybody on this side of the room, are we okay with that? Jennifer, what's up?
That's
Thank you for saving me for that
Mr. D.
embarrassing. That last rectangle from 15 to 20, I only use R of 15, but not R of 20. Good save.
wait, is that not the right endpoint?
Left endpoint method. They were asked to do the left. Adriana, what'd you get for your numerical value here?
I'm at 2,128.
2,128.
0.765.
765, and the units have to be gallons. Folks on this side, did everybody come up with that? Yeah. David, can you tell me about the right endpoint method, what your setup was?
Oh, yes. So first I saw that the interval was 0 to 20.
Yep.
And so then I divided by the number of rectangles.
Yep.
So I got 5.
Okay, partitions, still 5.
Yes.
Good. Tell me about your setup for the right endpoint method.
And so I put 5
5.
parentheses F5 plus.
I'm sorry, what?
Oh, R5.
R5.
R5 plus F10
Plus what?
R10
Plus R10,
plus R15
R15.
plus R20.
Okay, folks on that side of the room, is everybody okay? Noemi, what'd you get for your numerical value?
665.3502.
665.302
3502.
gallons. And everybody's good? Okay, so here's the question. Overestimate or underestimate?
Over.
Underestimate or overestimate? Now, it's easy to see from the numbers that they're overestimates or underestimates, but go back to the graph. Go back to the graph. I want to hear from somebody on the left endpoint method. How did you know in the beginning, before you did any calculations, that you were going to have an overestimate? How did you know from looking at the graph? 1 person, 2 people, 3 people, 4? Jonathan, how did you decide left endpoint method had to be overestimate?
You start off with the T of 0.
Uh-huh.
And then you go from the left to the right. So, and it's already over the line.
When I do the overestimate, no matter how I make that rectangle, doesn't it have to be an overestimate?
It sure does.
Now, it's not because it's the left endpoint method, it has to do with the behavior of the graph. What's the graph doing?
Decreasing.
The graph is decreasing. If your graph is decreasing, left endpoint method has to give you an overestimate. So I'd say because R of t is decreasing. And over here, right endpoint method is going to have to be underestimate because we're decreasing. Okay, part E. Part E, based on your answers to D, what's a reasonable estimate for the actual value? If you just had to make an educated guess, a good, smart, educated guess to what the true value is without using the calculator, Mariah, what would you do?
Just look. 1,000 is in between. Wait, never mind. It's
You know
1,000,
that the
right?
665 is an underestimate. Hold on,
Yeah.
and the 2128 is an overestimate?
So it's like 1,000.
So, now does the area have to be 1,000?
No.
No, but there is something that you know for sure. The thing that you know for sure, Anthony?
It's in between them.
It's between 665 and 2128. Somewhere in between. Think like a really smart, well-educated person here. If you wanted to minimize your error, what would you do? What would your guess be? Jasmine, what would be a good guess?
I would ask the teacher and then divide by
So if you wanted a good guess, what I heard you say is the left endpoint method plus the answer from the right endpoint method and divide by 2. And so that'll put you exactly halfway in between. Which means the biggest your error can be is from whatever this number is to your endpoint. Okay? Tonight's homework is to get this whole thing finished. So this is parts A through G. It's all, come on in. It's all calculator active. I'm picking this up tomorrow as a problem set grade, which means it counts for twice what today's did. This is meant to be a good thing to boost the grades up a little bit. Don't use F, use R. David.